So after knowing about indices and surds, let us now look at the topic which generally does not come directly, but its application is necessary to solve at least 2 to 3 questions in any CAT exam. Yes, we are talking about sequences and series, and let us look at some of the basic concepts in this first part, which are definitions of sequences, series, and progressions, and some of the properties of progressions that you should remember. So let us quickly jump into the concepts. So see, any set of numbers is called a sequence when you can find a definite pattern. For example, 1, 1, 1, 1. So all elements are 1. Then this is considered to be a sequence. Also, 1, 2, 3. The set of natural numbers is also a sequence. And 3, 9, 27, 81, and so on is also a sequence. So any set of numbers wherein you can find a definite pattern that is being followed throughout the sequence, throughout the set of numbers is called a sequence. Yes, a sequence is a numbers arranged in a definite order. Now, if this is a sequence, then what is a series? Series is the sum of terms in a sequence. So for example, for this sequence, the summation will be 1 plus 2 plus 3 plus so on. And for this, the summation will be 3 plus 9 plus 27 plus 81 and so on. And then what will be a progression? So a reduced formula of a sequence is called a progression. So here see, this is the set of natural numbers, right? Wherein the nth term, which is denoted by Tn, is equal to n, right? So if you put n is equal to 4, then you will get the fourth term as 4, right? Now, if you look at it, then what will be the nth term here? Correct. It will be 3 to the power n. Why? Because 3 to the power 1 is 3, 3 to the power 2 is 9, and so on. So you must have gotten a gist of what is a sequence, a series, and a progression. So tell me, out of these two sets of numbers that I draw, what is a sequence and which one is not? So see, the first one is 1, 4, 7, 10, 12, 16, 19. So this is the first set A, and the set B is 3, 5, 7, 9, 11, 13, and 15. So tell me which one is a sequence out of these? Yes, B is a sequence. Why? Because each term is 2 more than the term just preceding it, correct? So this is a sequence. So that is pretty much it about sequences, series, and progressions. Now, there are some common progressions that we generally encounter in our quants paper. So let us see which are those. Arithmetic progressions. So arithmetic progression means the subtraction of any term by the term just preceding it is constant. So we saw the set of natural numbers, right? 1, 2, 3, 4, and so on. So any term, when subtracted by the term just preceding it, then the difference that comes is constant. So difference is 1. Here it is 1. Here it is also 1. Correct? Now, what do we consider is we consider A as the first term and D as the common difference. So in this particular sequence, the first term is 1, this is equal to A, and the common difference D is also equal to 1. Now, there is a formula of representing this sequence in the form of a progression. So the general formula for the nth term is Tn is equal to A plus n minus 1 into D. Now, do you remember what was the nth term for this? Tn is equal to n, right? So put A is equal to 1 and D is equal to 1. So 1 plus n minus 1 into 1, which is equal to n minus 1 plus 1, which is n, correct? So this is the formula for the nth term of an arithmetic progression. So let us check an example. Set S is equal to 2, 6, 10, 14, 18, 22, and so on. Right. Now, what is the first term? What is the common difference? And what is the nth term? So see, the first term is A, which is equal to 2. The common difference, 6 minus 2, it is 4. 10 minus 6, it is again 4. So common difference is 4. And the nth term using this formula is 2 plus n minus 1 into 4. Right? Now there is another formula which is for the summation of these. So Sn is denoted by n by 2 into 2a plus n minus 1 into d, right? So here, what will be the Sn for the set S? Yes, it will be n by 2 into 2 to the 4 plus n minus 1 into 4, which is equal to n by 2 into 4n, which is 2n square. So these are the two formulae which you need to remember in the case of arithmetic progression. Now let us look at some of the properties of arithmetic progression. So the first property is that T1 plus Tn is equal to T2 plus T n minus 1 plus T3 plus T n minus 2. Okay, there will be an equal to sign over here. Equal to so on. Now, why am I telling this? See the formula that we just saw of the nth term. Tn is equal to A plus n minus 1 into D. Now put n is equal to 1. So T1 is equal to A. T2 is equal to A plus D, and so on. So put A here, put A plus n minus 1 into D here. Then this is A plus D, this is A plus n minus 2 into D. So the summation will be equal to 2A plus n minus 1 into D. Now, do you remember where did you see this? Yes, it was present in the sum of first n terms. So that is the second property, which is Sn is equal to n by 2 into A plus Tn. So if we know the first term and the last term and the number of terms, then we can also find the summation of those number of terms, right? So these are the two things. Now, let us see a question which can be solved, and therein we will also discuss the third property of arithmetic progression. Yes. So this is an actual CAT question only. For any natural number n, suppose the sum of first 10 terms of an AP is n plus 2n square. And then if the nth term is divisible by 9, then the smallest possible value of n is. Okay. Now, the first thing that we can do is Sn is equal to n by 2 into 2a plus n minus 1 into d. Now let us expand this formula. So this is equal to n square d by 2 because n into n plus n into c. Here is a 2a and here is a minus d. So this will be equal to a minus d by 2 because there is a 2 in the denominator as well. So this is the expanded formula and this is given to us as 2n square plus n. Now match the coefficients. So from this we can get that 2 is equal to d by 2. This means that d is equal to 4. Now here a minus d by 2 is equal to 1. So a is equal to 1 plus d by 2, wherein d is already 4. So this is equal to 1 plus 2, which is 3. And from this, we can say that Tn is equal to a plus n minus 1 into d, which is 3 plus n minus 1 into 4. Now, the nth term is divisible by 9. So see, for the nth term to be divisible by 9, it is for sure that this has to be a multiple of 3 because multiple of 3 plus multiple of 3 will yield a multiple of 3 and a multiple of 9 is also a multiple of 3. So n minus 1 is equal to 3k. So what can be the values of n? N can be 1, 4, 7, 10 and so on. Now see, for n is equal to 1, the first term is 3. For n is equal to 4, the first term is 3 4s are 12, 12 plus 3, 15. So for these n, Tn can be given as 3, 15. Then for n is equal to 7, it is 27. Then for n is equal to 10, it is 36 plus 3, 39. And so on. Now see, nth term is divisible by 9. So 27 is divisible by 9. So the minimum possible value of n is 7. So this was the longer way to solve this question. But had you known one thing, then you could have solved this question in 30 seconds only. And what is it? It is the third property of AP. So if we are given the summation in the form of Pn square plus Qn, so Sn is equal to Pn square plus Qn, then we can say that A is equal to Q plus P, D is equal to 2P, and Tn is equal to P into 2n minus 1 plus Q. So this is the formula for the first term, the common difference, and the nth term. And you can also cross verify it by putting in the values. So here you can see that q plus p is equal to 3, right? And d is equal to 2p. And here you can see this formula. So that is pretty much it for the arithmetic progression. And now we will look at the second and the most interesting type of progression, which is the geometric progression. Now, in the case of geometric progression, the division of any term by the term just preceding it is constant, which means that the example that we saw of 3, 9, 27, 81, and so on. This is a geometric progression, and geometric progression is often referred to as GP in the short form, and the arithmetic progression can be referred to as AP. So this is 3, 9, 27, 81, and so on. Now see, the ratio of the two consecutive terms is constant. So 9 divided by 3, 3, 27 by 9, 3, 81 by 27 is again 3. Now we will do the following considerations. A is equal to first term and R is the common ratio. So the first term is equal to A and R is the common ratio, which is 3. And A is also 3 here. Now there are two formulae in this case, which are Tn is equal to A into R to the power n minus 1. So see, if you cross verified with this particular example, so it will be 3 into 3 to the power n minus 1, which is 3 to the power n. And this is what we had seen a few minutes back, correct? So Tn is ar to the power n minus 1. And you can also comment on the Sn as a into r to the power n minus 1 upon r minus 1. So this is the formula of sum of first n terms of a GP. And this is the nth term of the GP. So if you want to make this thing over here, so what you can see is Sn is equal to 3 into 3 to the power n minus 1 upon 3 minus 1, which is 2, right? So this is the formula for the sum of first n terms of the GP. Now, let us look at the properties of the GP. So see, if you are given that three numbers are in GP, so you can consider the number as A by R, A, AR. If you were given four numbers in GP, you can consider A by R cube, A by R, AR, AR cube as the four numbers in the GP. And if you have to consider the five numbers, then you can consider A by R square, A by R, A, AR, AR square. So these are the five numbers in the GP. So this was the first point to be remembered in the case of a GP. Then the next point that comes is that, see, T1 into Tn is equal to T2 into Tn minus 1 is equal to T3 into Tn minus 2 is equal to so on. And this is equal to a square r to the power n minus 1. So it is pretty evident that if you put the formula of Tn, which is a r to the power n minus 1, then you will get this thing. Now let us look at an example. Let us say we have a question which says that the terms of a GP are 3, 9, 3, 6, 12, 24, and so on. Find T25. Now see, what you will simply do is A is equal to 3 and R is equal to 2 because 6 divided by 3 is 2, correct? So T25 is 3 into 2 to the power 25 minus 1, which is equal to 3 into 2 to the power 24. Now let us say you have another sequence as 6, 3, 1.5, 0.75, and so on. You have to find out S infinite, the value of it, right? So the formula for S infinite is valid when minus 1 less than R less than 1. S infinite is equal to A upon 1 minus R. So the sum of infinite terms of the GP here is equal to, what is the first term? 6 divided by, what is the common ratio? 0.5 upon 1 minus 0.5, which is equal to 12. So this is pretty much it about the GP. And now let us look at a question which has also come in the actual CAT. So let the mth and the nth terms of a GP be 3 by 4 and 12, where m is less than n. If the common ratio of the progression is an integer r, then the smallest possible value of r plus n minus m is. Okay. So see, the first thing that we can do is 12 divided by 3 by 4 is equal to, see, 12 by 3 is 4, 4 4s are 16. And this will be equal to r to the power n minus m. Why? Because 3 by 4 is equal to ar to the power m minus 1. And this is equal to ar to the power n minus 1. So 16 is equal to r to the power n minus m. Now, what is the value of 16 in the exponential form? It is equal to 2 to the power 4. Now, 2 to the power 4 equal to r to the power n minus m. And we need to have an integer r as the common ratio. So what we can simply do is take r is equal to 2, and this is also equal to 4 to the power 2. R is equal to 4 and r is equal to 16 as well. So this will yield r plus n minus m is equal to 2 plus 4, because n minus m will be 4 in that case. So this will be equal to 6. R equal to 4, this will be equal to 4 to the power 2. So 4 plus 2, again a 6. And r equal to 16. 16 to the power 1. So this will be equal to 17. So these are the three possible values of r plus n minus m. But since we have to find the smallest one, so it will be equal to 6. Now let us look at the third type of progression, which is the harmonic progression, wherein if we reciprocate the terms, the subtraction of any new term by the term just preceding it is constant. So it is nothing but an inverted AP. So in an AP, for example, we had the terms as 1, 4, 7, 10, 13, and so on. But in the case of a HP, so we denote it as HP, we have 1, 1 by 4, 1 by 7, 1 by 10, 1 by 13, and so on. So this is an AP and this is an HP. So that's like the introduction about HP. And now we will look at the fourth type of progression, which is a combination of two. Arithmetic geometric progression, which is often referred to as AGP. Now, what is so special about it? Let us see it with an example. So let us say the first term of a sequence is 2. The next term is 3 into, let us say, 5. Then the next term is 4 into 5 square, 5 into 5 cube, 6 into 5 to the power 4, 7 into 5 to the power 5, and so on. So can you spot something? Here we have an AP as well as a GP in the multiplication to it. So if you have to denote the nth term over here, so see, in every term, the first half is added by 1 and the second half is multiplied by 5. So you can say that here the nth term will be 2 plus n minus 1 into 1 into 5 to the power n minus 1. Right? So this is the formula of the nth term of the AGP, which is 2 plus, sorry. So the formula is a plus n minus 1 into d into r to the power n minus 1. Okay. Now, if you have to find out the sum of first n terms, do one thing, that let us consider this example only and say that this is S, the summation. So what you can simply do is multiply the summation by the common ratio, which is 5. So 5S is equal to, this is Sn, this is 5Sn. This is equal to 2 into 5 plus 4, sorry, 3 into 5 square plus 4 into 5 cube plus 6 into 5 to the power 4 plus so on plus n plus 1 into phi to the power n. And here the nth term would be n plus 1 into phi to the power n minus 1. And upon doing the difference, what you would get is Sn minus 5Sn, let us say. So you will get 2 plus 5 plus phi square plus phi cube plus so on plus up till phi to the power n minus 1 minus n plus 1 into phi to the power n. Now you have gotten a GP, so apply the Sn formula for it, and this is equal to minus 4 Sn. And putting it in the denominator will give you the sum of first n terms of the GP. And if you want to look at the summation of infinite terms, so the formula is equal to a upon 1 minus r plus dr upon 1 minus r the whole square. Contingent that r belongs to minus 1 to 1. For that purpose only, this formula is valid. So that's pretty much it from the first video. And in the next video, we will be looking at the types of means, the VN method for solving some of the questions, and the miscellaneous sequences.